Hello everyone, Goldie here. I am ready to dive into our lesson today, which is going to be on polymorphism, which is a super fun word to say and to throw around at parties. So we'll talk all about what polymorphism is, what it looks like. I'll give you a few simple examples. This lesson is really an introduction into polymorphism. We will see a lot of the executions of polymorphism and some of the harder problems we'll see on the exam. We're going to see those in lesson 4. But for now, we're going to get into talking about what it is and how we use it in inheritance. So it's a fundamental concept. It's one of the 4 pillars of OOP. And what it boils down to is allowing objects to be treated from different classes as objects of a common class. Okay, so it basically enables you to write code that can work with objects in a generic way without really needing to know their specific types at compile time. Okay. There's 2 types of polymorphism that we're going to go over. The big one is method overriding, and that's kind of the newer concept is method overriding. And then the second one, we use polymorphism when we implement interfaces. And we don't cover interfaces anymore on the CSA exam, but interfaces also use polymorphism. And those are the 2 main ways we use polymorphism. But there are 2 types of polymorphism, and believe it or not, one of them you've already seen before. We haven't called it polymorphism. This is the first time we're actually hearing the word polymorphism, but we have talked about static polymorphism. Another word for that we've used is method overloading, and we've seen that before. So it occurs when 2 or more methods in the same class have the same name, but differ in the number or types of their parameters. Right? So they have to be in the same class, same name. They just have different number, like a different amount of parameters and different data types. The method that is determined, that will be determined to be called, is decided at compile time, and it's based on the method signature and the types of arguments that are provided when you make the method call. This compile time polymorphism is also called early binding because the decision is made in the compile phase. So before you run your program already knows what method it's going to run. Okay, so that's static polymorphism. Dynamic polymorphism, that's the new one we're going to talk about a lot. Okay, it's also called method overriding. So this occurs when a subclass has a specific implementation of a method that is already declared in its superclass. Okay. So it has the same method as its super, but it does something differently in that method than its super does in its method. And the appropriate method, which one you use, is actually determined at runtime, and it's based on the type of the object, okay? The created type, the instantiated type of what that object is. It's decided at runtime as opposed to compile time with static. And because we decide this at runtime, it's called late binding is another word for it. Okay, so that's dynamic polymorphism, and because that involves super classes and subclasses, that's kind of why we talk about polymorphism in the inheritance unit. Let's review static polymorphism. Again, you've seen these examples before, you've worked with them, but it's always good just to kind of refresh your memory on what happens with these methods. So again, it's compile time polymorphism because the method resolution, meaning the decision of what method to use, is decided by the compiler at compiler time. Okay, we do static polymorphism through method overloading, which we talked about in Unit 5. Okay, so we're going to have multiple methods with the same name, but they have a different amount of parameters and potentially different types of parameters. And those differences are what allows the compiler to determine which method signature is appropriate to run at runtime, or excuse me, at compile time. Um, and it's considered faster than dynamic because it's resolved at compile time, so the program doesn't have to actually make a decision while it's running. But for our purposes in this class, it really doesn't make much of a difference. Just more of a fun fact for you. So here's an example, and I think we might have done this example or something like it in Unit 5. But notice the code, I have 3 methods, and they're all static for the purpose of this, but you can technically have it for a object creating class as well. So I have 2 methods called getArea. Okay, getArea, and you see they have different parameters. One has a single integer parameter, and one has 2 integer parameters. Okay, the return type does not matter in static polymorphism. Okay, you can't just have the same name, same parameters, and different different return types, remember. Okay, and I got my main method right here. Okay, so my main method is going to run. You see I have 2 calls to getArea, one with the 1 integer and one with the 2 integers. And when it's compiled, it's decided which method is going to be run at compile time, right? So with a single integer, you know you're going to run this method right here, and you're going to return whatever this value is. Okay, so 5 gets passed to radius here. You got math.pi times math.pow, 5 comma 2, so 5 to the 2nd power. So that's pi times 5, 5 squared. Okay, and that's going to return whatever that value is and print it off. This one, because it has 2 integers, the compiler says I'm going to make the decision to do this method. And so 5 gets passed as the length, 4 gets passed as the width, and you just have a 5 times 4, so 20 gets returned as a double there. So hopefully that's good review. Let me click through this and just show you, 5 gets passed to radius. We execute that. That's what's going to get printed off on your console as a double. Looks exciting. And then 2 integers here go to the top method, getArea, returns 5 times 4 as a double, 20.0. Okay? So that's static polymorphism. But in AP CSA, if you're in that class, we refer to it more often as method overloading. Okay, we don't really call it static polymorphism, even though that's what it is. We call it method overloading. Okay, so method overloading, that's what this is. Dynamic polymorphism, or sometimes we just call it polymorphism in general. This is when we have an inheritance relationship, and we are having classes and having objects behave differently based on what they are, okay, what they're defined as. So it's runtime polymorphism because, again, the decision is made at runtime, because you can have objects sort of change references throughout your program, as we'll see a little bit more in lesson 4, next lesson. But because you can have objects that change, kind of change their type throughout a program, that's why this is a runtime decision as to, okay, I need to run the method that the object currently is when it's in the program. Okay. So this is also called method overriding. So we got overloading and overriding. Okay. So this is specifically method overriding. So it's when your subclass has a method with the same name that's in their parent, but it just implements it differently. Okay, it looks very similar to static polymorphism, where we have methods with the same name, except this time the methods have the same name and they have the same number and type of parameters. Okay, they look the exact same, but they're in 2 separate classes, as opposed to method overloading, where they're the same name, different parameters in the same class. Okay. So again, which one you run is determined by the actual type at runtime. And the actual type of an object and the references, because they're references, they could change what they reference throughout the run of a program. So that's why it's decided at runtime. Okay, it's very flexible when you do have a lot of objects. It just allows you to support different classes and what they need. The examples we see in this class will just more be, okay, can I trace it? Do I know what it does? Why we use it? I'll give you an example in lesson 4. I'll show you with array lists how it's useful, but otherwise we don't really dive into that too much in this class. Okay, it's a topic we're going to introduce, make sure that you can trace and understand, but the why we use it and when we use it comes a little bit later in computer science courses. Okay. The example we're going to look at here of dynamic polymorphism in action is actually the say something method in person, student, and AP student. You'll see that the say something method has the same method signature across all 3 classes, but it's implemented differently for each of those classes. So let me show you, me remind you, if you have your person, student, and AP student class sheet, go ahead and get that out so that you can follow along. But I'll pull it up on Replit right now so you can see what it's looking at. So this is our person class right here, and we have this say something. Okay, so it doesn't return anything, it just prints off I am a person. Okay, and it's say something empty parameter list. In student, we also have say something. Okay, the exact same method signature, say something empty parameters, but notice how it does something different in here. It says I am a student. Okay, and then same thing with AP student. If we look here, we have the say something method, empty parameter list, I am an AP student. Okay. So all 3 of our classes have the same method signature, but something different happens inside each of those methods. And the logic behind that is because even though all 3 of these objects do the same thing, right? They all say something different. Okay, and that's kind of the logic behind polymorphism. And when we use objects to represent things and ideas in the real world, is sometimes we want them all to do the same thing, but we want them to do it differently. Okay, so that's what you're going to see. Oops, sorry. Let me get rid of this Replit screen and go back to the slides here. So here's just a little example. I got Marco, Manny, and Max. So Marco, Manny, and Max, a person, student, and an AP student. Okay, and created just with their default constructors. So then notice how Marco, Manny, and Max are all going to say something. Okay, and up to this point, if you were to see this code, you'd think they all would print the same thing, right? Because say something is a specific type of method, so they probably all do the same thing. You're not passing any different parameters to change the method in any way. They all have the same method signature. But they're going to print off something different because there are 3 different objects, and this is polymorphism. So when Marco.say something, because Marco is a person, Marco is created as a person, at runtime it says, okay, Marco is a person, so I'm going to go to the person class, I'm going to look for the say something method, and I'm going to run the say something method that I find. And say something in person says I am a person. Same thing with Manny.say something. Manny is a student. So Manny is created as a student. So at runtime, it's going to say, okay, I'm going to go to the student class. In student, I'm going to look for the say something method. And it's going to find the say something method, and I am a student gets printed. Okay. Remember with inheritance, so Manny, the say something, because Manny is a student, we go to student. If I don't find the say something method in student, that's when I would go back to person, and I would go up the hierarchy to person, and then I would try to find the say something method in person. Okay, so that's the inheritance behind methods that we've talked about. But because we have a polymorphic method here, say something is in student. So it's going to see that first and run that first. It never sees the say something method in person. It's never going to run into that. It runs into the say something method in student first. And that's the same thing with Max. Max is an AP student. So AP student, it's going to look through the AP student class, it's going to find the say something method, and it's going to run I am an AP student. Yeah, polymorphism in action. So these are pretty straightforward examples here. Again, the flexibility of polymorphism and some more intense examples are going to be covered in lesson 4. And that's when we get to upcasting and we have some different situations and different things we need to think about when we apply polymorphism. But for right now, this is it. This is the basic. Just a couple of notes that you may or may not run into in this class, but definitely you will if you continue on with your Java education. A subclass cannot override a public method and make it super. Okay, so you have to have the it does go the other way, I believe. You can make a private method public in your subclass, if I'm remembering correctly, but you can't override and make a public method private. Okay, so in this class, I would just say don't change your visibility modifiers. Okay, don't change public, private, don't switch, don't worry about that. Okay, all methods are public in our classes that we've been writing. A subclass may not override static methods from its supers. So if you do have a static method and you want to create a polymorphic method in the subclass, you cannot make another static method. Okay, there's no sort of polymorphic abilities with static methods because they are inherently non-object related. Okay, so static methods can't have dynamic polymorphism. Okay, yes, yeah. Oh, here, I said it. Look at that. Methods that are private in super may be overridden in the subclass. See, I knew. Don't worry too much about those visibility modifiers. Again, all instance variables are private. Most of our methods are public, so try not to worry too much about it, but those are a few notes about that dynamic polymorphism in terms of visibility modifiers and statics. Okay, last thing we're going to talk about in this lesson is method chaining with super. So we've done the keyword super with constructors, and we've seen how super works with constructors. We can also use super with method chaining, okay, and using it with calling methods from our superclass within a subclass. So we use the keyword super when we are in a subclass. The keyword super, just like with constructors, the keyword super is used in a subclass to refer to its superclass. Okay, so it's used in a child to refer to its parent. And using this method chaining with super is useful if you want to extend or customize the behavior of your supers method, but you still want to be able to use it in some way, okay? So by using this super keyword, you can call on a method from the superclass as part of a subclass's method and then add anything additional you want. So I'm going to stick with a super simple example just to demonstrate how this works, okay? So I have three classes, three very simple classes, farm, cow, and Angus. Okay, farm, cow, and Angus. So farm just has a make sound called noise. Cow extends farm. It also has a make sound. And notice it has a call super.make sound. Okay, so that super.make sound means you're going to call on the super's make sound method first. So make the sound, call on the super's make sound method, run it, and then come back and print off what you want, right? Angus extends cow. It also has a make sound method. This time it's going to print off something, and then I have a call to my super. Okay. When we use the super keyword with constructors, that super constructor call had to be the very first line in our code segment. Okay, super had to be the first line. When we use the super keyword with a method chain, it can come at any time, like you have here in the class Angus. Okay, so let's see a little demonstration. What is printed when the following program runs? So I farm A, cow B, Angus C. So I have A dot make sound, B dot make sound, C dot make sound. Okay. So let's trace through and see what happens here. So A dot make sound. A is a farm. So I'm going to just make noise. Noise, make sound, noise. That's all that gets printed, right? A dot make sound, farm, make noise. B dot make sound. B is a cow. So I'm going to go to the cow class and I'm going to run the make sound method in cow. Okay. Now what happens here is I have a call to my super make sound. So that happens first. So I take a pause, I go up to my super's make sound, and I run that. So it's going to print off noise, and then I come back and I print off moo. Okay, so noise gets printed off because that super call is first. And then I come back and I print off moo. Okay. And then C dot make sound. C is Angus, so I go to my Angus class and I run the make sound method in Angus. Okay, so that's there. So I'm going to print off beef, beef, because that happens first. And then I have a call to my supers make sound. Now, when you call your supers class, it's going to go to the one right above it in the hierarchy and look for that make sound first. So it's going to go one above into cow and look for the make sound method there. If it doesn't find it in cow, then it would go back to farm. But it goes one up first and looks for it in there, and it finds it. So what happens in there? Well, I have a super call there. So I chain up to super farm make sound, which is noise. Okay. So noise gets printed off first, and then that ends that. Then moo gets printed off again, and then that ends this. Okay. So the last two lines that get printed are noise and moo. Okay. So what's displayed, what's printed, this is the final result that's printed to the console. Look good? Sound good? Sound good? Get it? Oh. Sorry, that's not my best one. I can do better. I'll try better next time. All right. Yay, that's the end. So that was polymorphism. We didn't get too much into the inheritance hierarchy. We're really going to dive deep into that in lesson 4. So what the inheritance hierarchy is, we've already seen it, but we're going to talk a bit more about it and how we use it with upcasting and polymorphism. Okay. So thank you so much for watching this lesson, and I will see you next time.